All right, so we're going to calculate Google's beta. First thing you want to recognize is that I just downloaded a bunch of data from Yahoo Finance. I just said, and you can see I did this a couple years back, said I want 5 years worth of weekly price data for Google. And it gives me too much information. So I'm going to delete the first 4 columns. I don't need that stuff, right? So on October 24th, 2011, we opened at 586. The high for that week was 600. The low for the week was 587. Closed at this. And this is the volume. We don't need all that stuff. I'm just going to use the rightmost column, which is called the adjusted close for Google. All right? Adjusted close just means that we're adjusting for things like stock splits. So like if Google split their stock this next week, then the stock would sell for $300. And it would look like Google went down in value when it didn't. They just split their stock, right? So we got to be careful about junk like that. So here's Google's price from 1 week to the next. So notice, again, 5 years worth of data. So let's go all the way down. So in October of 2006, if you bought Google, you paid $475.02. If you owned it for a week, right, then what? You lost money, okay? One, question or answer?
Those are all dollars of that.
Correct. All right. So if we looked back and saw and said what was Google selling for at that time, that's what it would be selling for. So what would be our return? Well, it would be this minus this divided by our original investment. So we would have lost, in percentage terms, 0.7% that week, right? Okay. What about the following week? Well, we would have made money, right? We would have made a little bit. What about the following week? So on, okay? So we can do every week if we want to get to each weekly return for Google. So does everybody see what does this 12.92% represents? That represents the 1 week return. If you bought Google at 563, why do we have to turn this into returns? Because that's what the data requires. We're trying to figure out when Google is up 10%, what is the market doing and vice versa. So I've now got my Google figures, right? Now what do I need? I need to know what the market's doing during each of those weeks. And so I'm going to scroll over here to the Russell 3000 and do the same thing. Right? So first, make this a little bigger so you guys can see. Second, get rid of the junk that we don't need. Russell 3000, give it a better label. Calculate my returns. Right. So here's what the market did this week. Do you remember what Google did this week, this final week of our sample? Up 1%. So in fact, let's paste it over. And let's be careful and paste, oh boy, okay, I want to paste values. All right, you're not going to give me that, but that's okay. Let's see what happens. Yeah, I got to go back over. Hold on, time out, relax, no worries. Let's just do both, it'll be simplest. Okay, so when Google is up 1%, market's up 1.6, all right? So if we just looked at that data point, we would guess that Google's beta is what? More than 1 or less than 1? All right. It's the way that I presented the information process. When the market's up 1.6, Google's up 1. So Google is less than the market, so its beta is less than 1. It'd be like 0.7 or something like that. But again, that's only one data point. And, oh boy, that's far. Let's copy this formula down so we can look and see what the market did. Again, it's not perfect. Let's look at this next week. When the market is up about 1%, Google's down. The next week, when the market's up 6, Google's up 15%. So now we need to run a regression line because we've got lots of data. Right? And so how do we run a regression line here? First of all, we have to identify the dependent and the independent variables. What's the independent variable? Is Google driving the market, or is the market driving Google? We're thinking that the market return explains Google. So the market is the independent variable, the Russell. Google is the dependent variable, all right? That's why I was trying to be careful and putting it on the y-axis, which is consistent with the stuff that you get from QTM, right, from data modeling. So how are we going to run a regression? In this case, some of you might already have, if you click on data, you might see data analysis as a menu option. If you do, fine. If you don't, know that, and this is the other reason why I'm recording this, because you might not have that tool pack in there and you'll have to go fetch it. Under File, Options, Add-ins, you can see it as a choice that you have to load in. And it'll take a few minutes to load in, but it's there, okay? Sure. File, Options, Add-ins. And it's the Analysis Tool Pack, okay? I don't know about Mac. Data analysis for Mac? Okay. All right, so let me work through this, and then you guys can work it out, all right? So I'm just going to click on data analysis, look at all the choices I have. I'm going to go to regression, click on OK. Now I'm going to type in my Y range. So my Y range is my, let's see, Y is dependent variable. So that's Google's return. There it is, E2 to E262. And then I'm going to type in my market range, and that should be C2 to C262, right? Let it do its magic. Make this bigger. It's not pretty, but this is the answer. We now have an estimate for Google's beta. Which one of these is it? A lot of numbers on here. Coefficient on the variable, 0.97. So Google's beta estimate that we've calculated ourselves is 0.97. How does that compare to Google's beta today, or as estimated by this data source? And you can use a Bloomberg terminal. What do we got? 1.2. So Google's beta is a little higher today, or they use different data. Jeff?
So pretty much the beta just shows how much it fluctuates against the market.
Yes.
And if it was 31, it moves exactly with the market.
On average, okay, it moves with the market.
So that's how you get the beta.
The beta that you get, remember, data modeling is driven by the inputs, right? So do you think that we would get the same beta if we use the S&P 500 as our definition of the market? No, but it's probably going to be close, right?
The beta you just showed us was from Japanese finance, right?
Correct.
And I have a Windows page and it says 0.94
For what?
for Google.
For what data source?
Windows page, I don't know what the source
Okay. So it's a
is.
Bing?
Yeah.
So I don't know who Microsoft partners with. No, but this is real, right? So the range is between,
One and four.
call it 1 and 1.2. So, and this is all their current data. And so what other inputs could be driving this? The definition of the market that's used, or the time horizon, or the frequency of the data. Those three choices are yours. Um, and the data that you see, it's a can, right? We always use the most common methods are either 2 years of data or 5 years. It's either weekly or monthly. So I tend to see 2 years of data or 5 years of monthly data. But if it was me doing this as part of an investments class, I would ask a simple question to try to understand the risk of going forward. So what prior do you think most recommend? And what would I want to do? I want to use more recent data because IBM of 1 year ago is valid. IBM 10 years ago, not the same company at all. Right? So I kind of only want to use the most recent data, but I want a lot of data too. Right? I mean, imagine just using what I just used yesterday. Because that's I want to increase the data, but not go back too far. But I also might want to stay in a business because I don't know what's going to happen to the market. And what if my estimates only covered a period where the market was up, or only a recession? That would be a problem. Judgment calls. But you can see that there's 20% plus or minus, right? From one to another. And another way to think about that is, let's look at our data source. It gets worse, people. Okay? And this is why we're doing this today. It gets worse because how much explanatory power does this model have? At Yahoo Finance or Bing, and we're seeing a data for Google of either 1 or 1.2. Get an idea in our head about how risky this is. But this is a model, and we have to look at the goodness of data. How much does the independent variable explain movements in the dependent variable? What statistics do you use to evaluate that? Adjusted R squared, okay? Okay? R squared or adjusted R squared. In a simple model, it's going to be the same, right? So pretend like you didn't see this up. Pretend like you're in George's class. So you're in George's class, and you're running regression models, or whatever George does in his classes. And he says to you, okay, let's talk about R squared. What's a good R squared? Closer to 1 the better. And what's a good R squared? 0.8, 0.9, maybe 0.7, and then down to your 0.5, George is shaking his head and saying, this is just not a good model. 0.4, this model sucks. 0.2, and he's out the door saying you can't use this data. Right? The world of statistics are all accurate statements. It is theory wrong. The world of finance is messed up. And so in this case, with this model, estimate Google's. I'm not hot. Okay. What's our adjusted R squared? So if you're in you're going, this model sucks. Estimating percent of the stocks move with one factor, you're a rock star. Okay? So I've done a lot of these in the past. And we'll do Nike next week, you'll do Starbucks. 50%, that's hot. It's typical to see R squared at 30%, 20%. Think about what you're trying to do. You're trying to this is software. It just has to do with the movement of the S&P 500 or the Russell. So of course you're not going to get it perfect. market drives Google, you look at what? The t-statistic. Look at that t-statistic. That p-value is pretty much, which means that this is a very important variable in what drives Google. And so that's why we want to do this. Get our arms around the fact that there's actual data underneath this. I've heard much about the intuition, like what a beta means, how we use it, things like that. But I think it's worth a little bit of time to explore so that we know that it's not black and white, that there's a lot of gray, right? There's noise in financial data that's hard to overcome. Can we overcome it? Sure. If I'm Merrill Lynch, I have a multi-variable regression model that has 109 variables in it to explain stock prices. Then I can get an R squared of like 80%, and George will be happy. The problem is that what happens when it doesn't perform very well, and I can predict 109 variables. So this is the model that tends to get used most often in the world of financial management. In the world of investments, we would make an adaptation to this and use something called the Fama-French model. But that's a story for an elective or another time, or when we're drinking scotch at some bar somewhere. Okay? Anyway. Okay, so that's estimating Google's beta using, did I just say, this is recorded too. I'm going to get into trouble. I just remembered that. So like George Reck would say,